Hello everyone. So this video is to to um, help you with calculations involving reacting masses, which is something that students find a little bit tricky. But I'm going to use this analogy to hopefully help you understand um, how how it works. So let's say, for example, um, I have a car body. Okay. 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 And a car body will need four wheels. One, two, three, four. Okay. And together they will make one whole car. Okay. So there's a car body and you've got your four wheels there. Okay. So if we look at it in terms of ratio, I have one car body which requires four wheels, which will make one whole car. Okay. But the questions that you'll be given, they won't necessarily give you the number of moles. They will tell you the masses. So with the masses, you have to work out what the answer is. So let's say, for example, this car body weighs 1,000 kilograms. Okay. Let's say each of these wheels each weigh 10 kilograms. Okay. That's a total of 40 grams, 40 kilograms, sorry. So that's 10 lots of 4 lots of 10, which is equal to 40 kilograms. Okay. Now together, this whole car will therefore have a total mass of 1,040 kilograms. Okay. So hopefully that makes sense. Now, in the question, they might tell you that they won't tell you you've got four wheels. Okay. They might tell you you've got 80 kilograms. Now, you need to work out how many um, moles that is, okay? Like how many sets, if you like, how many sets of this, which is how many moles, okay? And in order to do that, if you are told that you've got 80 kilograms worth of wheels, okay, how many sets is that? Okay, so if each of these wheels is 10 kilograms, 80 divided by 10, you've got 8 wheels in total. Okay, 80 grams, you divide it by 10, which is the equivalent of the relative atomic mass or relative formula mass. That, that means 80 kilograms, there are a total of 8 wheels. Okay, that makes perfect sense. Now, the next thing we need to do is look at the ratio. Okay, now the ratio to wheels to body is that I need one body for every four wheels. I've got 8 wheels here, okay, which is twice as much. That means I will need twice as many car bodies. That means the mass of car body that I will need would be 1,000 kilograms multiplied by 2, which will give me 2,000 kilograms. I need 2,000 kilograms worth of car body. Okay. Now, if I wanted to work out how many total cars I can make from these 8 wheels, again I look at the ratio. So if I need 4 wheels to make one whole car, if I have 8 wheels, that will be twice as much. So therefore, I look at the mass of one car, which is 1040, multiply that by 2, which gives me a total of 2080 kilograms worth of car. Okay, so I hope that analogy makes sense. Now we're going to look at it in a proper chemical reaction. Okay, so we've used the analogy of the car. Now we're going to actually use a real chemistry example. So the reaction that we're going to look at is calcium reacting with oxygen, which produces calcium oxide. Okay, now in this reaction, it's telling us that 2 moles of calcium reacts with 1 mole of oxygen molecules to produce 2 moles of calcium oxide. Okay, so the ratio is 2 to 1 to 2. Okay, now let's say, for example, they told you that you've got 10 grams of oxygen. Okay, so you've got 10 grams of oxygen. What they want to know is what's the mass of calcium do I need to react with 10 grams of oxygen molecules to produce calcium oxide. Okay, so the first thing you need to work out is the number of moles in 10 grams. And moles is equal to mass over relative formula mass. Okay, now in this case, I have 10 grams and the relative formula mass of oxygen molecule. So the mass of one oxygen atom is 16, and I have 2 lots of those. So therefore, it's going to be 16 times 2, which is 32. Okay. Now, if you take 10 divided by 32, that gives you an answer. Just quickly do that on my calculator. Zero 0.3125 moles. Okay. Okay, so I've just found out that 10 grams of oxygen molecule is equal to 0.3125 moles. Now, the next thing we need to look at is the ratio or the stoichiometry between oxygen molecules and the other substances. So if I wanted to find out how much mass of calcium I need to react with 10 grams of oxygen, I look at the number of moles. This is the number of moles of oxygen molecules. This is a 1 to 2 ratio. So I need twice as much of this of calcium. Okay, so if I take 0.3125 and I multiply that by 2 because I need twice as much of oxygen, that equals 0.625 moles. Okay. Okay, because it's less than 1. Now this is twice as much as this. Then I need to, in order to find the mass, I know that moles equals mass over relative atomic mass. Okay, so I just need a bit more space here. So I'll put the numbers in. I know the number of moles, 0.625 equals, I need to know the mass, and I know that the relative atomic mass of calcium is 40. So to find the mass of calcium, I take 0.625 multiplied by 40, okay, which gives me an answer of 25 grams. Okay, that's 25 grams of calcium that I need. Okay, hopefully you can see that. Now, the question might go on to ask you how much mass of calcium oxide am I going to produce? So again, I look at the ratio. I know the number of moles I have in 10 grams. This is also a 1:2 ratio, so I need twice as much in order to react, okay, which just so happens to be the same here. So if we do the same calculation, I've got 0.3125 times by 2, which is 0.625 mole. Okay, no surprises that you have the same number of moles because it's the same ratio. Okay, and then from there, I need to work out the mass of calcium oxide. Okay, so calcium oxide, if we have mole equals mass divided by the relative formula mass, the number of moles is 0.625. I need to find the mass. Now the relative formula mass of calcium oxide, calcium has a mass of 40, oxygen has a mass of 16, which makes 56. So the mass of calcium oxide that I need is therefore 0.625 multiplied by 56. That gives me a total of 35 grams of calcium oxide. Okay. And if we look at the law of conservation of mass, you can't create or destroy mass. Everything has to be conserved. So the mass of the reactants has to be equal to the mass of the products. And if we have a look, the mass of the reactants, we've got 25 grams of calcium and we have 10 grams of oxygen, which together makes 35. And if we have a look at our answer, it's 35 grams. Okay, so the law holds true and we've got our answers. That's it. Good luck, and if you need to rewind and go back and have a look at how the calculation is done, then by all means. Okay, all the best.